Today's lesson is on 4.3, which is corrosion of iron, and then we will also look at 4.4, which is solving the problem of corrosion. So let's begin. So here, just to start, we're looking at a vehicle here. It's showing signs of corrosion or rusting. So all the kind of like the brownish, reddish color. And we can also see that there's parts of or pieces of the metal are also flaking off. Okay, so it's showing a lot of corrosion and rusting. Here's some more examples. Here, iron and steel rusts when exposed to oxygen and moisture. Here we have, looks like kitchen utensils. And we talked about this, I believe, in chapter 1, where a lot of utensils now are made with stainless steel to prevent the corrosion. So again, this is showing rusting, and it is an example of a simple composition reaction. So what is corrosion? It's any process that chemically breaks down or degrades metal. So an example of corrosion is the rusting of iron. Most metals will rust, but the corrosion of iron and steel is a serious problem because these metals are widely used. For example, in buildings and bridges and vehicles and so on. And what happens is as the rust flakes off an iron structure, more metal gets exposed to the environment, and therefore more of it will rust. And overall, over time, the structure is weakened as more and more of that metal is exposed. So rusting, like I said, it's a simple composition reaction. So here we can see that iron, solid iron, is reacting with oxygen to produce iron oxide. And that is the chemical name for rust. The common name is rust. And although it's not included in this chemical equation, water is also required for rusting to occur. So we would normally have water showing here as well. Gold is a metal that doesn't corrode, and that could be one reason why many gold objects have survived for thousands of years, like jewelry and other tools and so on. But now, because of the corrosion of steel and iron, scientists and engineers are very concerned because it's going to weaken structures that are made of iron or steel. And for example, the rusting of steel is used to reinforce concrete in bridges and buildings, and this can cause these structures to fail and collapse. And repairing or replacing these structures costs millions of dollars. So we're just going to pause here and watch a quick video on corrosion. Okay, so the next section we're going to look at is 4.4, which is solving the problem of corrosion. We also saw some of the methods already in the previous video. So here again, when oxygen and water cannot contact the surface, metals such as iron and steel will rust. Here in this second diagram, we see this, it's a bridge, and we see that it's been painted. So paint can protect steel from corrosion. This bridge was cleaned with high pressure jets of water that will remove any loose paint and rust and other loose debris. And then the clean surface was then painted with this fresh layer of protective paint. And that's one method of solving the problem of corrosion. So painting. It's one way to protect metals is to give them a protective coating of paint. Painting over the metal prevents oxygen and water from reaching the surface of the metal. This explains why steel beams used in office buildings or on bridges are often painted with red paint. It's not the best way to permanently protect iron or steel because once the paint chips off Water and oxygen are free to attack the steel again, and then rust blisters will grow very rapidly. All right, so painting, it is one method, but it's not the best way. Next is a method called galvanizing, just like we had seen in the video. It's the process of applying a zinc coating to iron or steel. Basically, it involves immersing the metal in a bath containing molten zinc. Then it will coat the metal. So if it's an iron nail, it will coat that nail with a layer of zinc, and that provides a protective barrier between the metal and the environment. The galvanized coating will stick or adhere to the base metal, and it resists chipping and cracking. And the zinc coating actually becomes part of the surface of the steel. Some galvanized nails will also have a further coating called a polymer coating to increase the protection. Again, the polymers will help protect the metal from rusting. So in this diagram, you've got the base metal, and then we have the galvanized coating, and then we have another coating on top, the polymer coating. And this way, the nails can resist rust for many years. And another method is called a sacrificial metal. This is basically sacrificing one metal to keep the other metal from rusting. So it's used in, for example, underground oil pipelines. There are bars or ingots of a second metal, such as magnesium, buried with the pipeline. So the magnesium will corrode, but the pipeline will not. So in this case, the magnesium is sacrificed in order to protect the pipeline. And here is the chemical equation. So magnesium plus oxygen will produce magnesium oxide. And the reason it's done like this is because it's much easier and cheaper to replace the bars of magnesium than it is to repair a ruptured pipeline. All right, so here is just an example of sacrificial metal in a pipeline. So we have the buried steel pipe, and then it's connected here by a wire, and it's connected to this magnesium bar. So the magnesium is sacrificed to protect the steel pipelines. The steel pipelines also contain iron. And usually for this bar here, it's usually magnesium, zinc, and aluminum that are commonly used as the sacrificial metals. All right, so we have a couple videos here to watch, and then we have the 4.4 questions in the textbook.